Marine Energy Alliance, and Jan Skjoldhammer found a completely new way to do that, and he combines it with solar.
Thank you.
Jan, good morning. Yeah.
Good morning.
NoviOcean, this is what you built?
Yes, it's rectangular.
How much
float.
bigger is it in reality?
It's quite large. It will be 38 meters long in full scale, times 7 meters, 4 meters high, and lifting 600 tons in a 4-meter wave.
Okay. What is the unique selling point of this thing?
It's cost effective. It's very light in some way, 150 tons, but then produce an average output of 250 kilowatt in a medium location, up to actually close to 1 megawatt in 5-meter waves. But the main thing is that you have a huge output per year in average. That was
and also, you could choose between solar energy or wave energy. You thought, let's do both?
Well, we have the structure already. You see it here. And normally, floating solar, they have to build the structure, have the systems on board, and the cable. Well, we have the structure, and we have the cable, and the systems on board, so why not use it? So this one can have a fold-out system on the side, so 700 square meters of solar on top, and this, let's say, in the winter you have more wave power, in the summer there's more sun power, so they combine very well.
They balance out. Okay, well, you brought a little presentation how it works. I'm going to take this away so we have a better view, and let's take it away.
Thank you. Yes, we're saying that, first we're quoting actually Larry Fink, one of the famous hedge funds investors. He says, decarbonizing of the global economy is going to create the greatest investment opportunity of a lifetime, but also leave behind the companies that don't adapt. So we say NoviOcean, the right solution at the right time in history. Top right, you can see our unit out in the oceans outside Stockholm this spring. It's a prototype. And down right is the early iteration about 3 years ago. And here you see a simulation. You can see how it works. So the float is long, rectangular. In that way, you catch more wave energy per unit, which is important because it brings down the costs. And right now, you see the wave is going up on the side of the float. You get to 30 bars of pressure, and water is flowing up through the pipe on the side there, compressed water, hitting the turbine with 300 kilometers per hour, bang, and up to 2,000 liters per second. So we have then 5 megawatt of output in the rising phase. So, and this is 3-meter waves. You produce, if it is latched, in the range of 500 kilowatt. In high waves, you can go up to almost 1 megawatt. So the proof is in the pudding. On this left graph, it shows simulations versus real-time data from our NO2 prototype, tested offshore outside Stockholm. And you see the blue line is the wave, and the reddish one is the test data from the type itself, and the yellow is the simulation. And you can see on the top graph, you have the position in the wave, and the graphs match perfectly. The second graph is the vertical speed. Also, it matches, so we are confirming the simulations. The third one is the pressure, almost the same, small bump on the red line there, due to it's just natural wave. The fourth one is the pressure, and then the last one is the output. And the important thing is that here the simulation and the test are the same. So we validate the system, no doubt. On the right graph, we have extrapolated those simulations to the full-scale unit. You can see the same simulations, and lower right, you can see 1 megawatt of output power in a wave of only 4 meters. And that's also before latching. So we're saying now that the real performance matches simulation to the point. Not many developers can show this. Many talk about the rated power, we show it. That's very important. And also, this is done without latching. So it's that if we latch, we can have 60% more power. So this unit will give gross power of 1.6 megawatt. Net after losses in waves of 4 meters is 700 kilowatt. Waves of 5 meters is close to 1 megawatt output. And we have it validated. So it's also hybrid. So it's 500 kilowatt wave plus 120 kilowatt of solar. We call it the H-Pulse concept. It's a hydropower plant on top of the float, just a water turbine, like up in your mountains. And then it's triply patented, 20 countries. And we have a customer option for the solar panels on top. And we can also have storage on board, and later on also H2 production. And there's a common construction here for the moorings, the cables, and the control system. And other floating solar, well, they have a cost of 75% just for the structure, the cabling, and the systems. Well, we have the float, don't we? We have the cable and the systems. So adding PVs on top is just 25% extra cost. So it makes sense to combine these two to large units instead of having separate wave power and separate solar power. That's the way you get more output per system. And then also, of course, solar and wave is synergistic. In the winter, you have much more wave power. In the summer, you have more sun power. Plan forward. So we're now finished with stage 1, stage 2, and stage 3. And now we're going into stage 4, which is the full-scale pilot, 500 kilowatt. And we are well on the way there, and should be in the water in a test site outside Spain, most likely. Perhaps France, Portugal, it's not fully decided, in 3 years. Then a pre-commercial area, and then fully commercial. So we have about 3 million in funding by grants so far. We're looking for more. I think we'll have a good chance of getting 2 to 3 more next year. And we're looking for 9 million in funding, privately or with partners.
So if someone has a few million lying around, get to you.
Most welcome to contact me for that, seriously, and the pre-market valuation of 50. We have a team, 6 persons, full-time on left, and then board and other ones on the right. On the homepage, you will find links, videos, interviews, and also lots of documentation. We're very transparent.
Yeah.
And finally, Larry, think again, the next 1,000 unicorns, according to investors then, won't be search engines or social media, perhaps Twitter. They'll be sustainable, scalable innovators, startups that help the world decarbonize and make the energy transition affordable for all consumers. Thank you.
I'm now thinking of a floating unicorn, yeah. What are the ecological implications of your...
There's been lots of tests on that, investigation, and so far one has seen basically 0 negative implications. Actually some positive, because some of the organisms, they want to grow down here and make some, nests, basically.
Yeah.
So,
what does it do, let's say you install this in a existing wind farm.
yeah.
Is that possible? Because they already have the cables. Is that...
It is. The distance between the large wind power units is often 1 kilometer, because they have the blanket effect, because the wind is much less dense than water. So this can be placed either in front of the wind power units to mitigate the waves hitting the towers, or in between.
Because what are the consequences for this thing for waves? Do you get lower waves?
Yes, if it's placed around either in front of the wind power or along the coastline, you reduce the waves hitting the coastline by 30%. So for instance, for California, the expensive villas are falling into the water because it just scrapes up the shoreline. If you have this as a long line in the front, you can both have solar, wave power, and mitigate shoreline erosion.
So this thing works against raising sea levels at 2 ways.
Yes, you may say so. We can't, stop the sea level rising, but we can mitigate the shoreline erosion, definitely.
Okay, well, wonderful. Thank you so much. And let's hope someone here at the fair has 8 million for you.
Thank you. You're most welcome.
Thank you so
Cash
much.
power.